What do you call a guy laying in front of a, with no, laying in front of a door? What would his name be? I know it's kind of random, but his name would be Matt. Okay, let's move on. All right, so now we looked at evaluation, we looked at simplification. Now we get to look at solving. Solving will let us use evaluation or simplification, and then after we finish solve, we can evaluate to check our work. So now I'm looking at problem 1. I got 3n plus 2 equals 17. And remember, the purpose of this is I want to get that 3n by itself. So I do the opposite of how the 2 is connected together. So now I've got 3n equal to 15 because I'm going to subtract 2 from both sides. I now divide by 3, so n is equal to 5. Now, please notice how I showed you my work. I did not tell you, I told you I was subtract 2. I did not show that I'm subtracting 2. I told you I was divided by 3. I did not show it. And I'm getting you ready for what we're going to do in chapter 2 with working with proofs and doing algebraic proofs. I think that's when we start doing those. So make sure that you're careful. If you're showing now, that's okay. Whatever I do the one side of the equation, I'm still doing the other. I just happen to be a little neater with my work. In problem 2, I'm going to add 2 to both sides. Okay, 5a is equal to 2 plus negative 12, so it's negative 10. I'm going to divide by 5 and find that a is equal to negative 2. Now, in 3, doing the same thing, I am looking at each step, and after I do one step, I'm going to show you the result. So I'm going to subtract 4, and I have 2x, so 10 minus 4 is 6. And I divide by 2, and it's x equal 3. Now, in each one of these, I could plug back in this value, and I can evaluate. 3 times 5 is 15, plus 2 is 17, and check my work. And I can plug this back in, and negative 2 times 5 is negative 10, minus 2 is going to give me a negative 12. So I'm checking it to make sure it's right. And I got 3 times 2, which is 6, plus 4 is actually 10. So those are working out. Now, in this next one, I want to show you something because I've got choices sometimes, and sometimes when I do some things, students go, "Oh, well, that's never something I've ever learned." But other times you go, "Oh, well, I can do it that way, so that's kind of cool." But I want to talk about it real quick. Generally, when people come across this problem, they'll go 3n minus 12 equal 15 because they distributed everything going across, and then they start solving. They're going to add 12 to both sides. So I have 3n equal 27. And they're going to divide by 3, so n is equal to 9. Now, that's perfectly fine. It's an answer that totally works. I take that 9, I plug it into n, and 9 minus 4 is 5. 5 times 3 is 15. Another way of looking at this problem, what if I divided by 3 first? If I divide by 3 first, now I know n minus 4 is equal to 5, because if I divide this by 3 and this by 3, I dump the 3, that's where my n minus 4 came from, and 15 divided by 3 is 5. At this point, I can add 4 to both sides, and n is 9. It's the same answer, a little less work, and I've justified where I've done my work. Okay, so you have a choice when you do that. It's up to you. Both are correct. In 5, 6, 7, and 8, go for it. Go ahead, work those. Make sure you're getting comfortable with them, and then we'll do it. I'll come on, and after you turn me back on, and we'll correct it. In 5, I've got to get the y's together. Okay, so when I get the y's together, I'm going to subtract 2y from both sides. So 4 is equal to 6y, because 8 minus 2 is 6. Now, I've got to be careful here. I want to solve for y. I want to know what the value of y is. So because of that, I want to do the opposite of how they're linked. This is 6 times y, and I want to divide by 6. When I do that, I got 4/6 equal y. I just created an F word. I know, fraction. It's just kind of a scary thing, but because it's a fraction, I have to reduce it. 4 and 6 both have a factor of 2, so this is 2/3. So y is 2/3. Now you probably on your calculator went, well, you know, Bloom, I put it in my calculator and this is what happens. Let me get these colors off my calculator for a second. And you were like, well, gee, 4 divided by 6, that's 0.6667. So a lot of people will say, well, that's 0.7. Well, that's true if I asked you to round it to the nearest tenth. But since it's a non-terminating, always repeating decimal, because it's always 0.6 and your calculator rounded up right there, it's more correct to leave it as a fraction 2/3. And we want you to become friendlier with fractions. So I want you to be thinking fractions are friends, not foe. Okay, fractions are friends, not foes. So let's go on to 6 and let's get this thing going. I've got my z's I got to get together. These are actually more than the 2 steps. I got to get my variables together before I solve. So I'm going to get the -6 over to the right. And the only reason why I'm doing that first is that I'd be working with a positive value on my term with the z. Okay, so I've got 1 is equal to 13 plus 3z. I subtract 13, I get -12 is equal to 3z. I'm going to divide by 3 and I get -4 is equal to z. And I'm comfortable working with that way. And whether you did it the other way or this way, -4 is our value for z all the time. Now again, in 7, that's a negative or a subtract, so I'm subtracting here. So I'm going to distribute that and combine like terms before I do other things. So I've got 6 minus 3t minus 4 is equal to t. I'm going to combine like terms, so I've got 2 minus 3t is equal to t, and 2 is equal to 4t. And just like everything else we've always done, I have a situation where I'm solving for t. So I'm going to divide by 4, and I'm going to get, if I bring this up, I'm going to divide by 4. I got 2 divided by 4 is equal to t, and that's 1/2 is equal to t. So that's really my solution. 1/2 is equal to t. And I'm just going to double check. So I have 6 minus 3t minus 4t. I've got -4, 2 minus 3t. That's me 4t. Yep, I'm happy with that. Okay. So I'm just going to condense that down. Nope, I don't need to. We got plenty of room. So now in 7, in 8, I'm looking at this idea. I'm going to distribute the 2. Now, this is much like this one up here, number 4, but because the 2 doesn't go in the 7 evenly, I'm just going to decide to distribute the 2. Okay, but since it's 2 and it'd be terminating decimal on the 7, I could go 3.5 and I could work with it that way. But I'm just going to distribute the 2 because it doesn't go in the 7 nice and neat. And this is going to be plus 9. So I've got -2 times 4 is -8. -2 times -4.5 is 9. I'm going to subtract and I get -2 is equal to -8n. Again, I'm going to divide the value that's with my variable. That's why I'm going to come up with -2 divided by -8n, which really is just 1/4 when I reduce. Okay, and it's just equal to 1/4. That's my final answer. Now, I'm hoping you start to notice that the further along we're going, the more technical these are getting, and the more care I have to pay attention with my signs, my order of operations to undo everything. In 9, this looks really tough, but you see that subtract? The subtract follows everything, so this is really just w plus 5. The parentheses just drop away. Minus 5 is equal to 2w plus 5. Because now there's nothing outside these parentheses for me to do anything with, I look at that and that's going to be 0. So w is equal to 2w plus 5. I subtract 2w from both sides and I get -w is equal to 5. So I divide and I know that w must therefore be -5. Okay, we got 3 left here on these, and I want you to be careful about stuff. Now I'm going into fraction land. I know, Bloom said the F word again. Fractions. I want you to know that we're going to treat this differently. But before we even get to that, this is just going to be blob. So I got blob minus 10 equal 30. Well, any time I've ever done this, I do the opposite of minus 10. So I'm going to add 10. So 5/7 p is equal to 40. Now, I'm not sure if you guys remember reciprocals, because when I divide by a fraction, that is the same as multiplying by that fraction's reciprocal. And reciprocal is just putting a fraction on its head. Okay, so this is the fraction's head, the 5. So if I multiply this by 7/5, that becomes 1. If I multiply this side by 7/5, p becomes 56, because that becomes 8, and 8 times 7 is 56. Now that's a fast way of doing this problem. There's another way of doing this problem. If I could do it this way. Again, it's 5p over 7 equals 40. Notice how I rewrote my fraction. Anytime I have a whole number times a fraction like this, the way it is, that letter actually goes to the numerator of the fraction, not the denominator. Now I'm going to multiply by 7 to clear out my fraction. So I've got multiply by 7. So I got 5p is equal to 280. Okay. That's 4 times 7 is 28, and a 0. And I divide by 5, and guess what? It's going to be 56. So both ways will work. I like multiplying by the reciprocal. It's faster. But, as you ease yourself into these, just practice both. Be comfortable. Now, in 11, I have a fraction with my variable. And multiply by the denominator of the fraction, I will clear the fraction. And so what that means is this. I am going to take, and I'm just going to get rid of this stuff here a little bit so I have some room. I'm going to take and multiply both sides by -3. Okay? And I'm multiplying both sides by -3. What that's going to do, I'm going to have m plus 9 equals -3. Now I'm multiplying everything by -3. I'm going to add 9, and I got m is equal to -12. Now I've got some folks out there going, Bloom, seriously? -12? Let's just check this one. We're going to evaluate this. So according to the original, if I go -12 divided by -3, remember I just plugged that in, -3 is equal to 1. Well, that's 4. -3 is equal to 1. Hey, that totally checks out. Boy, that really does work. That's cool. Now in 12, go for it. See what happens. Do the distribution, do the combining like terms, see what's going on. So you got 5k plus 2k plus 2, because I distributed here, equal 23. This is 7k plus 2 is equal to 23. I'm going to subtract 2. 7k is equal to 21, and I find out that k is 3. Now, we got 2 problems left, my word problems. I know I alluded to them earlier, but I want you to think about this. Twice a number subtracted from 35 is 9. Twice a number subtracted from 35 is 9. If I have twice as much money as you have, and you have $10, how much do I have? Everybody's screaming 20. By the way, you're talking to a video, it can't hear you. So twice a number subtracted from 35, twice a number, and that number is unknown. So twice a number, and they say, ooh, subtracted from 35, twice a number subtracted from 35, twice a number subtracted from 35 is 9. So I'm going to subtract 35 from both sides. So I got -2x is equal to, if I go 9 minus 35, remember, some people, when they're doing this, they don't believe me when I come up with 26. So I've got, and it's -26 minus 35, and it's going to be -26. At least it should be. And somebody should go 9 minus 35, not 9 minus 32. 9 minus 35. Okay, should be 26. -26 is what we get. So we're over here. We got -26. And now I divide by -2, and x is 13. Now, Did you notice that I read that like 3 times and I reordered stuff after I wrote stuff down and they say, what is the number? So let's just double check. So I got 35 minus 2 times 13, and that's 9. So that checked out because that's going to be 26. 35 minus 26 is equal to 9. Sorry, I kind of did a little faster in my head. Okay, so in 14, this one looks really tough, but it's not so bad. The Johnsons pay $9.95 a month plus 3.5 cents per minute for local phone service. And people are like, where did he get 3.5 cents? This is 3 cents and this is half a cent. So 3.5 cents per minute for local phone service. Last month they paid $12.75. That was their big bill. I wish I could do $12.75. How many minutes of local calls did they make? So the total is $12.75. Okay, and now I'm looking at this and I've got, well, I got 3.5 cents per minute, but I'm doing it in terms of dollars. So I've got my 3.5 cents per minute, and I'll call that M, plus my monthly pay, no matter what, is $9.95. Okay, so that's my setup. And it's the setup you got to reread and think about. This is my total cost. This is my monthly cost plus my cost per minute. Now I subtract my $9.95, and I've got to get my calculator back out here. So I'm going to go over here. I got $12.75, 12.75. Somebody has to actually have a 12 there. 12.75 minus my $9.95. And I'm just going to double check to make sure those are my numbers. $9.95 a month. I hit enter. And that's $2.80. So I've got $2.80. $2.80 is equal to 0.035 minutes. So I'm going to find out how many minutes of local calls we made. So 2.8 divided by 0.035. So I'm going to go divided by 0.035. Remember, that's 3.5 cents. So that's 80 minutes of calls. So 80 is my answer. So 80 minutes of calls. Okay, that's what we've got. We're all good. I hope things went well. Have a great day.